Hello everyone, myself Goel, Assistant Professor in the Department of Electronics and Communication Engineering, Ajay Kumar Garg Engineering College. I welcome all of you once again in the video lecture of Communication Engineering. So till the last lecture we have discussed in communication systems what are the basic elements we require. One of the very important element of the communication system is modulation. Modulation is a process that is used to be performed at the transmitting side. So today we are going to discuss in detail what is modulation, what is the need of modulation in communication system, what are the various types of modulation. So let us start with the introduction of modulation. What is modulation? Modulation is a process in which some of the characteristics like amplitude, phase or frequency of a high frequency signal that is commonly known as a carrier signal is changed according to the instantaneous value of the information or the message signal. We know that information or the message signal is a low frequency signal that is also known as a baseband signal. So what is modulation? It is a process of varying some of the properties of a high frequency carrier signal according to the instantaneous value of the message signal or the information signal. Modulation is a process that is to be performed at the transmitting side to achieve efficient and reliable transmission of the information from one point to another point. We know that our message signal is generally a low frequency signal and we used to call it as a baseband signal. So here I have represented a message signal that is usually a low frequency signal. Then we need a carrier which is generally a high frequency signal. What is a carrier signal? How we can define this carrier signal? It is a high frequency periodic waveform that carries this low frequency or the message signal to the other end. That is why it is called as a carrier signal. This high frequency periodic waveform is used to carry this low frequency message signal or baseband signal. That is why it is called as a carrier signal and it is a high frequency signal. We cannot directly transmit this low frequency signal to a far away distance. If we do so, then there are some challenges in transmitting this low frequency or message signal to a far away point. What are those challenges? We will discuss those challenges in coming slides. But before that, we need to understand what modulation is actually. So we have a low frequency signal that is not compatible or is not suitable to directly transmit over a long distances. So we need a high frequency periodic waveform that will carry this low frequency message or the information signal to a far away distance. Now the question comes, how this high frequency carrier signal will carry this low frequency message signal. So we know that a signal can be represented in terms of its amplitude, phase and frequency. That means a signal will have these three basic properties: amplitude, frequency and phase. So by varying any one of the property, that is amplitude, frequency or phase, we can superimpose this low frequency message signal over this high frequency carrier signal. It will vary depending on if we are varying amplitude of the carrier signal, if we are varying frequency of the carrier signal, or if we are varying phase of the carrier signal according to the instantaneous value of the message signal, that will become that type of modulation. That we will discuss what are the different types of modulation. But what do we understand here? What is modulation? It is a process of superimposing low frequency message signal over a high frequency periodic waveform that is called as a carrier signal. Why we require to superimpose this low frequency over this high frequency carrier signal, that means what is the need of modulation? Let us discuss why there is a need to convert this low frequency signal into a high frequency signal. So, the very first requirement of converting this low frequency signal into a high frequency signal is to get the practicability of antenna. That means this modulation will help us to reduce the height of the antenna, that is the length of the antenna. How we can reduce the height of the antenna? What is the role of height of antenna in communication system? For example, if we are transmitting our signal wirelessly, then the size of the antenna plays a very important role. The size of the antenna, or we will say the length of the antenna, is generally proportional to the wavelength at operating wavelength of the antenna. Lambda, that is the wavelength of the antenna, we know we can define lambda is equals to c upon f, where c is the speed of light, that is 3 into 10 raised to the power 8 meter per second, f is the operating frequency. For example, if I want to send a voice signal and the voice signal is of 3 kilohertz, the frequency of that voice signal is 3 kilohertz, and I want to transmit this voice signal over a long distance, then what height of antenna I require to transmit this voice signal of frequency 3 kilohertz? Let us calculate. If f is equals to 3 kilohertz, then lambda will become 3 into 10 raised to the power 8 divided by 3 into 10 raised to the power 3. So, lambda will come out 10 raised to the power 5 meter. The length of the antenna, which is generally proportional to the wavelength of the antenna, and moreover in most of the cases this length is equal to the quarter of the wavelength that we quarter of the wavelength. So, lambda we have obtained for a voice signal of 3 kilohertz as 10 raised to the power 5 or 100 kilometer divided by 4, that will become 25 kilometer. So, to transmit a voice signal directly without any modulation of 3 kilohertz frequency, I need a antenna of length around 25 kilometer, which is practically not possible. For this, what I can do, if I will do the modulation, if I will convert this low frequency signal into a high frequency signal, for example, if the frequency after modulation will become 3 gigahertz, then the value of lambda will become 0.1 meter for the same. And for the same signal after modulation, the length of the antenna required will become around 2.5 centimeter. So, after modulation, this height of the antenna or this length of the antenna is practically possible. To realize an antenna of this height is feasible. So, modulation will help us to reduce the height of the antenna or the size of the antenna. The next requirement of this modulation is that it will help us to perform a very important function, that is frequency multiplexing, and the third one, that is the avoid of mixing of signals, that is it will help us to reduce the interference. What is the meaning of frequency multiplexing and avoid of mixing of signals? That is, if for example, if there are 5 persons in a room and they want to talk to a person at the same time, then 5 of them will have almost same frequency of the voice signal, then that person will not be able to listen anything. In the similar scenario, if we are having 5 persons, and they want to transmit their signal through a common channel, then the person at the other end will not get anything, because 5 of these will have the same frequency of their voice signal. The audio signal or the voice signal of 5 of them will be very close to each other. So 5 of these signals will get mixed to each other, and it will transmit them without performing modulation through a common channel, that at the other end we get nothing but noise only. So how we can reduce or how we can eliminate this problem? It will modulate each of this signal at some other high frequency with the help of a different modulating frequency, and then after performing the modulation will transmit all of these signals through a common channel or through a common medium. Then at the receiving side, after performing the demodulation, we can receive the signal without any interference or without minimum amount of interference. So this modulation will help us to reduce the interference or mixing of signals. This example that I have taken here is a type of frequency division multiplexing. That means we are sending multiple signals at different frequency after performing the modulation over a common channel. What is multiplexing? Sending many signals simultaneously over a common channel without any interference. So modulation will help us to reduce the height of the antenna, which is very important if we are transmitting our information wirelessly. It will help us in sending multiple signals over a common channel. It will help us to reduce the interference. What amount of reduction in the interference we will get, that we will discuss later. And it will also help in narrow banding. What is narrow banding? It is almost similar to the length of the antenna. The length of the receiving and the transmitting antenna, there should not be a very large or huge difference between the height of transmitting and the receiving antenna. So this modulation process will help us in managing that ratio. So these are some of the needs of the modulation in communication system. So after discussing or after understanding what is modulation, what is the need of modulation, now let us discuss what are the different types of modulation. As we have seen in the previous slide, that a carrier signal which used to carry high frequency carrier signal which used to carry the message signal can carry this information in 3 ways. That will depend on the property of this carrier signal. We can mathematically represent this carrier signal in amplitude, frequency and phase. So it will vary the amplitude, it will vary the frequency, it will vary the phase, then that will become that particular kind of modulation. So these are the 3 basic kinds of modulation. What are the other different types of modulation? Let us understand. So first of all, we can categorize modulation depending on whether we want to perform analog modulation or digital modulation. So we have digital modulation and then we have analog modulation. Before that, the modulation can be categorized depending on the high frequency carrier signal. The carrier signal that we are selecting, if it is a continuous wave like this, then it will come under the category of continuous wave modulation. how we are categorizing or how we are dividing this modulation. We are dividing this modulation on the basis of the massive signal that we want to transfer is a analog signal or a digital signal. Secondly, the carrier that we are using is a continuous wave signal or a pulse signal like this. So, if our carrier, first we will see ki what are the types of modulation if we are using the carrier is a continuous wave signal. So, if our carrier is a continuous wave signal, then we can categorize our modulation further in two categories, that is amplitude modulation and angular modulation. Under angular modulation, we have frequency modulation and phase modulation. What is amplitude, phase and frequency modulation? If the amplitude of this high frequency carrier wave will vary according to the instantaneous value of the massive signal, then it will called as amplitude modulation. If amplitude is varying of the carrier signal, then simply it is amplitude modulation. If like this, if this is some random amplitude of the massive signal and this is high frequency carrier signal, then after modulation what kind of signal I will have? This, the modulation or sorry, the amplitude of this high frequency carrier signal will vary according to the instantaneous value, that is the amplitude of the massive signal. So, I will have a massive modulated waveform like this, that we will discuss later in detail also. So, what is amplitude modulation? If our carrier is a continuous wave, then and if the amplitude of the this high frequency carrier wave will vary according to the amplitude of or the instantaneous value of the massive signal, then it will be a kind of amplitude modulation. If the frequency of this high frequency carrier wave will vary according to the instantaneous value of the massive signal or the information signal, then it will become frequency modulation. If the phase of this high frequency carrier signal will vary according to the instantaneous value of the massive signal, then it will called as a phase modulation. Basically, these are the three basic types of modulation, that is amplitude, phase and frequency modulation. Now, if our carrier signal is not a continuous wave, but it is in the form of pulse, then we can categorize pulse modulation further in two forms, that is digital modulation and analog pulse modulation. In digital modulation, our information or the massive signal will be in the form of binary, that is 0 or 1. So, if our information is in binary or is in digital form and our carrier is in pulse form, then we have further categorization of digital modulation as pulse code modulation, that is PCM. Okay. Under this digital modulation, we have some more categories like ASK, amplitude shift keying, FSK, frequency shift keying, PSK, phase shift keying, that we will discuss when we will study about the digital modulation. Basically, what is a digital modulation? It is nothing if our information that we want to transmit at the another end is in the form of digital, that is in the form of 0 or 1, then we have to perform digital modulation. What is analog pulse modulation? If our information is a continuous signal and the carrier that we are using to transmit this information from one end to another end is in the form of pulse, then we will have analog pulse modulation. Under analog pulse modulation, we can transmit our information with the help of pulse amplitude modulation. That means if the amplitude of this pulse carrier signal will vary according to the instantaneous value of the massive signal, then it will be called as pulse amplitude modulation. Okay. Next is pulse duration modulation, or we can say pulse width modulation. If the width of this pulse signal, that is the carrier signal, will vary according to the instantaneous value of massive signal, then it is called as pulse width modulation. Okay. The next type is pulse position modulation, which is also called as PPM. The first one is also known as abbreviated as PAM. So we better call them PM, PPM or PWM. Pulse position modulation, the position of the pulse will vary according to the instantaneous value of the information signal or the massive signal. So depending on whether our information is in the form of analog signal or is in the form of digital signal, we will have two main kind of modulation, that is analog modulation and digital modulation. After that, depending on whether the carrier that we are using to carry that information is in the form of continuous wave or is in the form of pulse signal, we can further categorize the type of modulation as a continuous wave modulation or pulse wave modulation. In continuous wave modulation, we will have amplitude modulation, frequency modulation, phase modulation, pulse amplitude modulation, pulse width modulation, pulse position modulation under pulse modulation, and will have pulse chord modulation, amplitude shift keying, phase shift keying, frequency shift keying under digital modulation technique. All these types of different types of modulation now we are going to discuss in detail one by one in the coming units also. In this unit, we will focus on this amplitude modulation, where we will use a carrier signal is in the form of continuous wave. So let us start with this amplitude modulation, how we can perform or how we can vary. What is amplitude modulation? It is simply varying the amplitude of this high frequency carrier signal in accordance with the instantaneous value of the massive signal. So how we can do this variation, how we can superimpose our low frequency massive signal over high frequency carrier signal, we will discuss the method of generation, how we can then demodulate them, what are the method to retrieve our information, that is low frequency signal, back from the modulated signal, we will discuss now. So first we are going to discuss in detail, that is amplitude modulation. So as I was discussing, what is amplitude modulation? It is a process in which amplitude of the carrier wave is varied according to the massive signal or the information signal or the modulating signal. First we should have this clarity that this information signal, this signal, that is our information, is also known as information signal, massive signal, baseband signal and the modulating signal. Modulating signal means the signal that we want to modulate. Okay. So what is amplitude modulation? It is a process of varying the amplitude of this high frequency carrier wave according to the instantaneous value of this massive signal. Here I am having my massive signal, that is a sinusoidal waveform, periodic waveform. here I am having my carrier signal that will carry this information. How it will carry this information? With the help of this amplitude modulation. Here we can observe the amplitude of this carrier signal is varying according to the amplitude of this message signal. The moment the amplitude of my message signal is increasing, the amplitude of my carrier signal is also changing. The moment the amplitude of my message signal is decreasing, the amplitude of this carrier signal is also decreasing. So, the amplitude we can observe here, the amplitude of my carrier signal is changing according to the instantaneous, that is the amplitude of the message signal. In this modulation, we have three basic parameters, that is amplitude, phase and frequency. Phase and frequency. These are the three basic parameters that we can vary. Okay, so what we are varying? We are varying amplitude of my carrier signal. When I am varying the amplitude of my carrier signal, then rest of the two parameter will remain constant. That means there will be no change in the phase and the frequency of the carrier signal. So, in amplitude modulation, only the amplitude of high frequency carrier signal will vary according to the message signal, and rest two parameters will remain constant. Next, this amplitude modulation we can also categorize in 4 different types. That is, the first one, that is known as conventional amplitude modulation, or we also call it as a full amplitude modulation, or it is also known as double sideband full carrier modulation. What is conventional amplitude modulation, or we in short form we used to call it DSBFC, double sideband full carrier modulation. Will understand? Then the second type of this modulation is double sideband suppressed carrier modulation. Here we have double sideband full carrier, that is double sideband with carrier. The second type, double sideband with suppressed carrier, that means the carrier will be suppressed in the second category. The third one is single sideband modulation. The fourth one is vestigial sideband modulation. So, under amplitude modulation, we will discuss all these 4 categories one by one. So, let us start with the conventional amplitude modulation, that is double sideband full carrier, or simply the double sideband modulation. So, what is DSB full carrier modulation? We know in amplitude modulation there is a message signal. Now, we will represent our message signal, carrier signal mathematically to understand what amount of modulation we have to do, how our signal we can analyze our waveform or our information after modulation. So, in amplitude modulation or in any kind of modulation, we will have a information signal, that is a message signal, that is a low frequency signal, that is also called as baseband signal, and will have a carrier signal. Okay. So, in amplitude modulation also we will have a message signal and will have a carrier signal. In amplitude modulation, the message signal is required to be impressed on the amplitude of the carrier signal. We can represent both of them mathematically. Message signal MT we can represent as AM cos omega MT. What is AM? AM is the amplitude of this message signal or the information. WM is the angular frequency of the modulating signal. Modulating signal, baseband signal, message signal, information signal, all are the same terms. Okay. FM we know we can represent omega in terms of frequency, 2 pi FM. So FM is the frequency of the modulating signal in hertz. Omega m is the angular frequency of the modulating signal in radians. There is a difference of unit. If we are representing our signal in terms of omega, or if we are representing our signal in terms of frequency. Okay. So mathematically we can represent our message signal as am cos omega mt. Similarly, we can represent our carrier signal, which is a high frequency periodic waveform. It can be a sine waveform also, it can be a cosine waveform also. Our message signal can also be a cosine waveform, it can also be a sine waveform. Okay. So there is no issue, but to understand the process and the analysis, we have considered that mt is am cos omega mt, and carrier signal is represented as AC cos omega ct or AC cos 2 pi fct after expanding omega c. What is AC? AC is the amplitude of the carrier signal. Omega c is the angular frequency of the carrier signal in radian per second. If we want carrier frequency to be represented in hertz, then by putting omega c is equals to 2 pi fc, we will have the frequency, that is the carrier frequency in hertz. So here we have done nothing. Here we want to do the analysis of double sideband full carrier modulation. First we will understand the mathematical analysis, then we will see how we can generate the modulated waveform with the help of amplitude modulation. Here we have taken our message signal, we have represented message signal mathematically, then we have taken carrier signal and we have represented carrier signal mathematically. Okay. So what will be done later after selecting the message signal and carrier signal? The next step is to superimpose this message signal over this carrier signal. So the resultant waveform will be called as a modulated waveform, and this will result in a sinusoidal signal that is called as a modulated signal, the amplitude of which will be a function of the message signal. That means after superimposing this message signal over this carrier signal, the waveform that we will get will become a function, that is a modulated waveform will become a function of the message signal. The amplitude of the modulated waveform will be according to the instantaneous value of the message signal. Now how we can superimpose them, and after superimposing this amplitude of this message signal over this carrier signal, what kind of signal we will get? We will discuss this in our next lecture. This is all about this, where we have discussed the needs of modulation, why we require to perform modulation, what are the various types of modulation, and then we have seen what are the various types of the very first basic category of modulation, that is amplitude modulation. Thank you everyone.